Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Before start with this extra lecture, so regarding your IMC, Islamic Medical Education, previously known as IRK, Islamic Medical Knowledge. So basically, the coordinator for IMC for the whole phase 1, year 1, and even year 1 is Prof. Imad Matlub is the coordinator, assisted by Dr. Ahmad Kaid for the first year. So actually the whole IMC is being coordinated by not individual department. So even if you are in our block at the moment, so the coordination should be coming from them. Nevertheless, they already scheduled 3 lectures, all scheduled for Friday afternoon. The first one would be this Friday. I will take over from Dr. Razman because I'm the one who gave this lecture for many times. And then the next lecture would be given by Prof. Pakir on the 11th of July, the same time, 3 to 4. And then Prof. Imad himself will give a topic about reformation of Tajdid on the 18th of July. And on the 25th of July, you are supposed to have the case study preparation, which is the free time actually. I believe you are given case study preparation. Saya pun tak faham tanya MC ni pun. Because for us, in terms of EPID and public health, as I told many people, that I do not like to have a separate for Islamic perspective lah, Islamic lah. For me, everything is Islamic, so we integrated in the lecture. So if you can see that not all lectures, those one that relevant, then I will pinpoint certain element of Islam inside. Nevertheless, this is one of the effort being conducted. One of the effort to increase, just to have a different graduates compared to the other university. And initially, the name is IRK, Islamic Revealed Knowledge, but some people do not like the acronym. So especially Prof. Arif, so Prof. Arif changed to IMC, IRK, Islamic Revealed Knowledge. Even we have a kuliah of IRK in Gombak. Actually, in Islamic medical education, in our faculty established by the champion would be Prof. Umar Hassan Kasule, currently in Riyadh. He was with us for many years. I was in the same department with him. Previously, first year block 4 would be a combination of anatomy and epidemiology. Very weird, attend with credit course, and then I joined the department. I said something is not right here. How come the block 4 combination of anatomy, head and neck, and epidemiology, which is at the end of the day when we are required to set up a public PDQ questionnaire, it must always be a statistic about head and neck. Very difficult to create a problem. So we negotiated after the first review. We managed to have our own block, but we have to give 3 weeks to BMF, which is fair enough for the anatomy component. But instead of having anatomy in 4 blocks, now cramped into only 3 blocks. those are a bit history about. And then that time RK, the topic is the same, but the approach is different. We have objective for every year, and we have scheduled objective, and Prof. Umar is the champion. Prof. Umar Hassan is the scholar in the world. He's a public health specialist with a PhD and Doctor of Public Health from Harvard. So he's a very knowledgeable guy, a very nice Muslim. Very nice Muslim. Anybody knows him, have heard his talk? Always smile. I really like him a lot. We miss him. Okay, so give this one to your leader. This is a complete, actually. The complete. You know what happened to the second year, and who is the leader? Alright. So I hope you can approach Prof. Paki for the topic next one, and then Prof. Iman for that one. For case study, I'm not sure what you are supposed to do. What else? I'm supposed to tell you guys. This one. What else? Oh yeah. That one later, because I'm supposed to tell you guys about your poster presentation, because I already put up inside our website, so you can download later. The poster is actually in Microsoft Publisher format, so you must have Microsoft Publisher to open the template. So you are free to modify the template as you like, but my recommendation is to keep using the standard font. Why? Because we already changed. Later, I'm not sure that Niza mentioned to you already or not, but we bring forward the presentation from Friday to Thursday, because it's a very long presentation, and half an hour in the morning, the lecturers will evaluate the posters. So there are going to be 2 evaluations, one for the poster and then the presentation. I believe we are going to have a random sampling in terms of who will present first, because there would be an order effect. What is order effect? What is order effect? In 2006, when we conduct a national survey, National Health and Mobility Survey, NHMS, we have 3 NHMS. 2006, a psychiatric component, they have only 44% response rate. Meaning to say that if they distributed 100 questionnaire, only 44 people who responded to the questionnaire. The rest did not submit, because it's a self-filled questionnaire put inside envelope. Because we ask very sensitive questions. Because together with the self-filled questionnaire, there are 3 other modules. And one of the module, just before psychiatric questionnaire, is sexual behavior. Another one is regarding alcohol or drugs. We ask very sensitive questions. We don't really ask the name. We don't really ask the detail of personal information. So put everything inside the envelope. We seal the envelope and give it to the officer in charge. So that's how we do it. But only 44 people, 44% return. So psychiatric was a bit upset. So they asked us. I'm one of the team member, but I'm not in charge of the whole data collection. So we study, so we realize that there is an order effect. The psychiatric questions come after sexual and alcohol, all these vices questionnaire. So there are many people who are maybe offended by the question asked in the sexual, because talking sexual is taboo in our community. When you ask something very direct, some people might simply, I don't want to answer this question. I will not going to submit this paper. But then the last module, the 4th questionnaire, the self-fill, this is psychiatric, which is nothing. Whether they feel stressed, depressed, it's quite okay. But they put it to the last, in the one booklet. So what happens, people, when they don't want to answer sexual, they're not going to also answer the psychiatric. So that's what we predict happen. So everything in that module is only 44% response rate. Order effect. So when you present, I reckon there will be an order effect. Who will get the advantage? No. Normally, the mid, the presentation. Why? pro and cons lah. The first one, no benchmark. So if you set a very high benchmark, then you become advantage. The rest becomes disadvantage. Okay. But what if you present a very low benchmark? What happens? You become the disadvantage. Of course, you will be your mark. If they put 50, the rest become higher than 50. If you have 60, the rest will be higher than 60. So those are the disadvantage of the first group. Unless you can set very, very high benchmark of the presentation, of the mark. But the second, third group, maybe you learn from the Q&A. So you prepared already in your presentation. Therefore, when Q&A, there will be less question asked. But we will always going to ask you to put inside everything there with the PowerPoint. So you are not able to modify when your friends present. So those are the presentation. So poster. The template will be in publisher. I ask you to not, especially the font. You can change the font, but I hope you know the most commonly used font. Don't choose which is very difficult. And in fact, in actual poster presentation scientific, we don't use fancy font. Normally we limit to depend. One maybe sans serif font, another one is let's say Times New Roman. So those different font, sans serif groups, and then the Times group font. So you don't mix too many font inside. Anyone? I hope there would be a good graphic designer or someone who is good in using computer in every group. Because just like when in MasterChef, the food may be delicious, but if the presentation is not good, the mark will not affect. Presentation also very important. Do you believe in Islam? Now it is IMC component. Do you believe the external appearance is important or not in Islam? Yes. Some say yes, some say no. Yes. Is it really important? There will be people saying that don't judge the book by its cover. So as if the thing outside is not really important. Which one do you believe? Is it important outside? Both important. Okay. Good that you know that, because there is a story that one group of missionaries, Muslim missionaries, go to one country. So while the group and the Jamal inside the aeroplane, they met many people. And then they give salam to people inside. But some come to this particular guy, a very handsome guy, wearing a coat, clean shave, no hair definitely. So, and then the Jamal just don't want to give salam, not sure whether Muslim or not, isn't it? So just skip that guy. So that guy was offended, and he just met the leader of the group and asked, why this your group did not give salam to me? Because sorry sir, because I thought you are not Muslim. Do not judge the book by its cover, said the guy. Doesn't mean that I'm not having beard, not wearing a nice robe or what do you call it? Jubah, what is jubah in? Robe, okay, or kurta, whatever. It doesn't mean that I'm not a Muslim. Okay, we are sorry, because the point is, and then he said, the inside is more important than the outside. Okay, and then the Jamal went and they arrived at the destination, and then the Jamal asked this guy, are you a local here? Yes. Ah, good. Can you help us by sending this letter to our friends here? Fine, sure. So he gave the letter. And then the guys looked into the letter and said, to whom should I send the letter? Oh, outside is not important. Inside is important. So guys, your poster must also be good. The content also have to be good, but the appearance, the color you choose, the font you choose, the graphic, whether you want to do 3D, 2D, you really have to know this. Then it will give some influence to the whole whole content, the whole poster, the whole presentation. Quite similarly to the presentation, the slide that you have, the font that you use is very important. You yourself have seen so many presentations by different lecturers. You can judge. So for me, that is important. I learned from my teacher, that was important. That's why I'm now conveying the same message to you. Make an effort to improve the presentation, but doesn't mean that the color thing is good, but content nothing. So both must be equally good. Okay? So the poster, one, do not use the common font. Because second, when you email to your supervisor, later they will email to Niza and me for me to print. I will print. Don't have to print outside. We can cut costs. I have a printer in my room, which is department's printer, big printer, but not many people know how to use it. I will print for you. I can print very fast, one poster in 10-15 minutes, provided I don't have to modify. So you have to send me into version, one in the publisher, second one in PDF format. Therefore, I know whether the document changed or not. If you convert the publisher into PDF, so I know, this is, because I cannot change PDF. So you can send to me in PDF. If you know how, in fact, which is very good, you convert into a high resolution PDF. Then, I don't have to open publisher, I just print directly from PDF. But provided it has to be high resolution PDF. I'm not sure whether you know how to do that or not.
Yes.
If you know how to do that. So and then I'll print. I try to print. But if I hope the quality is okay. Okay. Now that's all. Any question regarding IMC and poster for your research? So both the template and the template for the proposal are put up inside the web. So you guys know the address. If you guys log into our Facebook, I normally put a lot of notice references inside. You know our Facebook? Okay, just search comment, COMMED, and like the page to get notified. Okay, now the sample size in research. So this is actually the component is being taught. That some is communication. The Shima somehow didn't realize this is part of the requirement. Actually, all the previous group we gave. And you have to consider sample size in your research. Okay. First, why we calculate sample size? Because we need enough sample for external validity. We must have enough sample for external validity, which is quite similar like this, to represent population. In research, have Dr. Hashima mentioned there will be internal and external validity to a research? Ada yes, ada no. Which one? Internal validity, the method should be sound, should be good, should be proper. The method is correct. Design you choose can fulfill or can answer the objective. The sample size done is good to detect the differences of what you want to achieve, and the sample size also required for external validity, which is can you use the data from the sample that you have to the population. If you are studying among you guys here, most likely the external validity is not really that concerned, because you will infer your finding to yourself. But what if you plan to infer your finding to all medical graduates, for instance, the junior medical graduates, so depending upon your discussion. So the ability to infer is what we call as the external validity. Internal valid is how you do your research. If your research is very good, it is valid. It will answer what it is supposed to answer. This is your objective, you achieve that objective. So sample size, enough sample size is required for this purpose. And you have to know the sample size for you to prepare the logistic. Of course, you are doing the research among yourself. It's very confined and very finite population. But what if in actual research? When we do National Health Mobility Survey 2006, I always mention the third one because I'm involved in the third one. And the planning of the subsequent one. But not outside that term. So, for example, in 2006, we have 24 million Malaysian. So we calculated the sample size based on the prevalence of certain diseases. So from that sample size, we have to sample 70,000 Malaysian. 70,000 Malaysian. So we know already. So we apply budget for 70,000. So we see the location where, and then we have a sampling frame, blah, blah. So we know where the locations are. So we estimate how much money we require. In total, we need 18 million Malaysian ringgit for 70,000 Malaysian that time. So logistic, you calculate the money. Second, you plan where to go, how many teams to develop, because now we're talking about Malaysia, the whole country. For example, the whole team travel, not the whole team, the team that is responsible for northern area, they travel to Langkawi just to see 4 people. 4 households, 4 houses. They travel all the way, but they cover the northern area, just to try to go and visit 4 houses. Of course, they are very happy because they're going to Langkawi. But not for us. You have to prepare the budget. But those who are in Sabah, they are not very happy. They have to travel interior just to see a few houses, few people in that rural area. Okay. So, logistic preparation. So, you have to know the size and also who are the sample. Who are the sample, you will learn from sampling technique. And we need sample size to measure the treatment effect. Okay, what is this term treatment effect? I believe you may not be able to understand. What is treatment effect? In English, literally, you know treatment effect. But in statistics, what does it mean by treatment effect? Example, if you are talking about new drugs, drugs X and diabetes mellitus, for instance. So how really good drug X compared to the standard drug? So the different effect. For example, when you use drug X, the HbA1c goes down. HbA1c is the measurement of the compliance of the drug, how good the diabetic control is. The lower, the better. If you use drug X, your HbA1c goes down by 5%, or 5% is a lot, by 2%, goes down by 2%. So the 2% is the treatment effect. So I'm talking about prevalence, percentage. I can talk about, I can even talk about millimole per liter. How much is reduced? So those are we call treatment effect. Okay, in general. So for you to detect the difference, so the difference goes down by 5%. But if your sample is not enough, you may not be able to detect the 5%. You detect 5%, but you are not sure whether that 5% is really real difference or just occur by chance only. In statistics, we are saying that there would be, in statistics, we use this magic number of 5%. This one Professor Fisher, introduced this number just for the convenience sake, 5%, which is 1/20. They would say that if there would be a possibility of error, if the error to this 5% is error, how to phrase? I must think first. If there is a possibility to make an error of more than 5%, error, that 5% is an error. That 5% occur by chance, not real treatment effect. By coincidence, you got 5%. If that possibility is more than 5%, so we cannot rely on. You can see that you just take only 5%. So the possibility of making error should be less than 5%. Then we can accept that the 5% is significant. If not, it is not significant. We want the error possibility to make that error, to make type 1 error. Okay, that error. Because I'm jumping into the middle of your syllabus, so I'm not sure. I hope my colleague will cover that later. So the possibility of making that error should be very, very low, so that you can very confident to take that 5%. Okay, now that 5%, there's a probability. When you learn at maths, you learn what probability, right? Kebarangkalian. So if the 5% is if the sample size is very big, many, you have the possibility to detect the difference. If the sample size is small, very unlikely you will detect the difference. Okay. Example, I give an analogy. Nowadays people are using bow, isn't it? Arrow, bow, archery. So you have a target over there. So everybody was given, let's say how many arrows, let's say 10 arrows. Hit the target over there. What is the possibility with the 20 arrows to hit that target? You know already. But whatever number is, doesn't matter, depending on the skill. Same person, now you give them only 5 arrows. What is the likely that he will hit the same with the same precision? Less likely. Because now the number of arrows is less. For him to hit the target now, the chance is very less likely. So if the sample is small, for you to detect this error just now, to find the difference is less likely. So you must have enough sample to detect the difference, the treatment effect. So how many arrows you need? At least you will hit 2. That now become a probability. How? So you must know certain sample size. Sounds very complicated, but as you go along, it's not that. So, and we sample, it shows that we don't do research haphazardly. I told you what is epidemiology. The first word is the study, systematic. So, sample size, when you calculate, you know exactly how many samples that you have. So when you have enough sample, you stop. If not, people keep asking, do I stop here now? Or should I collect more? So you will not going to be able to answer that question. So it becomes gut feeling. So it's not science. It's not science. So sample size is an estimate. And it will always remain an estimate. Sample size calculation. Because sample size is calculated before you do the actual research. For your planning. How many sample size do I need? For you to calculate the sample size, you must know the expectation. What will be the outcome? Something like, just now I mentioned, you have the target over there, you must have the expectation. You must have put some target objective. I want to hit at least 2 arrows on the board. Stick on the target board. At least, your aim. 2. If 2, what happens to the probability? Okay, better, rather than you put at least 5 hit the board. Now, it becomes more difficult, because now you want 5 arrows to hit the board. So, it depends on your objective. So, before you conduct your research, you must know already what is your expectation of the result. Then you can calculate sample size. So, sometimes people come to see me, Dr. Jamal, I want you to calculate sample size for me. Okay, I'm doing this study. How many samples I donate? How do I know? You tell me your expectation, then I know how to calculate based on your expectation. The sample size now varies based on expectation. So the issue here is that you calculate before you do your research. You only give or provide the expectation, the estimation of the effect. But you will never know the actual effect until you have done the research. That's why sample size remain an estimate, agak-agak, some intelligent guess. How to get this? I don't know whether I want to hit 5 or 2. So how? Normally people hit how many to say that it's good? Oh, 5. Okay, we use 5. You use the experience of others. Literature review. If your study is a novel study, something very, very new. So, you just agak-agak lah, because you are the best person who do research. You estimate yourself. How do I know? Don't ask me. I will calculate based on your expectation, not my expectation. Because I'm not the content expert. I will calculate for you. but you are the content expert. Because you are the one who proposed this study. You should know how much you want from the study. So you must have a specific purpose, and you must really know. And the sample size only meant for that purpose. And, okay, never exact value. So, calculated for certain expected estimates at certain degree of precision. So normally when you do something, you want to estimate something, you don't estimate one value. Example, when you join ONG or something in gynecology in year 3 later, you are supposed to do abdominal examination, and one of the thing that you have to examine is to estimate the fetal weight. You palpate the mother's abdomen, you measure the fundal height, use the tape, and you will just estimate the fetal weight, the fetus weight. So you have to estimate, especially when it comes near term, 36 weeks. Because if it is a very big babies, you should advise the mother to be delivered in the hospital, and you may even plan for elective cesarean section. You plan for cesarean section. Okay? If the baby is good, a second baby, the weight is just nice, it's around 2 point something kilo, so you can deliver normally. Just SVD, the delivery biasa. Okay, now you have to estimate the fetal weight. You palpate abdomen. So your consultant asks, how much? Okay, tell me the estimated fetal weight. The baby's weight is 2.553 kilogram. Oh. Oh. Macam tangan ultrasound. Isn't it? Even ultrasound also estimate. So, it shows what? No. So, what normally we do is from 2.4 to 2.6 kilo. Around 200 grams. So, that is already very precise actually, but that is possible. That is possible. It's possible. Huh? That is possible. You estimate, you look at the thickness of the mother's skin, and you can estimate whether the baby is really big or small, and you can estimate the size based on your experience. If you palpate enough, if you palpate enough. That's why it's very important for you when later become in 3rd year. I got complaint from your lecturers in clinical department. In clinical department, you guys only go to the ward when you have a teaching. That's wrong, guys. You have to be in the ward all the time. All the time, 8-5. During our time, it's 8 to 12 midnight every day. If you on call, different story. We have on call. Undergraduates follow our supervisor, our lecturer for on call, and we enjoy doing that. Okay. Okay, now. When you do research, I mentioned to you about specific purpose. So when you do research, you must always have the end in mind. That's why if you look at the proposal, I told my group, you look at the proposal, the template, one piece of paper, the most you can accept is both sides. Not more than two pages of proposal. The paper that we gave you cannot more than 2 pages. But don't use font size 4. Make sure it's standard 12 size font, yeah. So, what the last component that requested from that proposal template is dummy table. Dummy table means the main table to present, to answer your objective. The main table that will show the main objective. The whole research in one table. Table also means, I put there a dummy table, but example I give is a graph. Table also can have dummy, whatever, can be dummy output. Can be dummy graph, dummy, as long as that you can present in graphics, you can present also in tables, up to you. The one that you believe is the best. So what I'm trying to say here is that even though you are at the planning stage, you already plan how would you present your finding. Plan with the end in mind. Everything. That's why in Malay we have the term bijaksana. Ada term bijak sini? Tak ada kan? Ini Malay word. Bijak sana. No bijak sini tak ada. Mean to say that, and then in Islam we realize that our destination is always the other side of the life, not this life. So always at the end. So if we know what is our end, so we will behave according to where we want to be later at the destination. Similar like in this research. So we have to plan with the end in mind, and for the sample size, there is no one formula for all. No. I'm telling you there are thousands of formula. And I was not going to give you my slide. But on my last slide, I will tell you where you can download the documents. Very nice documents. So basically, I can say there are two major reasons you do research. One, you do research to represent population. Whatever estimate that you measure is to represent population. Your aim is, you sample small, but your aim is to represent, your aim is to get population-based information. At this point, normally the main variable only one. Example, prevalence of hypertension in this village. So how many variables involved? One. Hypertension? Yes or no? So hypertension, yes, is the prevalence over the denominator. Only one variable, which is hypertension status. Yes or no? But the next one is hypothesis testing when you involve more than one variable. Example, you want to prove, or you may want to prove, or you want to find out, or you want to measure, or you want to detect difference of prevalence between male and female. How many variables involved now? Two. Hypertension, yes, no. And gender, male, female. Two variables. Usually, if you involve more than one variable, it's supposed to be hypothesis testing. You want to test hypothesis. And people might ask, but doctor, if we do prevalence of hypertension in in one kampung, one variable, but then we want to check whether the prevalence increased compared to last year. That is also one variable, but they have hypothesis. It is not one variable, it is two variables. Hypertension, yes, no. Good year, current year, and last year. You can see that. When you start to compare, it always has hypothesis. But if you only have one variable, create hypothesis based on one variable. Anyone? Try. Create one hypothesis, one variable. Try. Cannot. That's why when I say hypothesis, when in your study, research, you plan, you want to compare, it's always hypothesis testing. So you decide which one is your main, but sometimes people have both in the research. So which one should they calculate for? The ideal is always calculate for hypothesis testing. The ideal. But if you do that, sample size can be extremely big because you want to test hypothesis inside the population. Whoa, becoming bloated. Huge sample size. For National Oral Health Study 2010 completed, or now we plan for the pediatric 2015, another one. We have to negotiate which one we can afford, which one we can't afford. We measure the sample size. We modify our precision, our expectation. We cannot have precision to be very, very precise. So we allow precision to be wider. So our sample size becomes smaller. If not, we can't afford the study. So you have to modify those elements. So sample size is actually a negotiation between what you can do and what is the ideal sample size for in ideal situation when the money is not an issue, when the time is not an issue. So you negotiate. How to negotiate? manage your precision, manage your expectation. Don't expect the result. At the end of the study, I expect the prevalence is to be 40%. But I told you cannot be one figure, kan? Plus minus 0.0001%. That percent, that precision. So your sample size is 1.5 million Malaysian. Big. You can't afford to do it. So lower your expectation. 40% plus minus 5%. So now, reasonable. Then you calculate the sample size. So at the end of the day, your sample size is able to detect something around 5%. When the difference is lower than 5%, your sample may not be enough. Precision up to 5%, yeah? Plus minus 5%. So if the precision actual is actually lower than that, you might not be able to get, because the arrow that you use not enough to detect that small target that you decide. Because your target now very small, you are using certain arrow, you cannot hit the target. If your target becomes smaller, how many arrow you need? More arrow you require. At least one possibility to hit one at least, or 5, whatever, inside the board. If your precision is very big, sample size is small. You can hit, okay, tutup mata pun pas. Because the board is big. So, and then when you have that sample size is a minimum required sample size, but you have to adjust in reality. If you want 100 people, and then you go and visit them, for instance, especially, not necessarily that this 100 will agree to participate. Some might reject. In fact, if you go to urban area, Putrajaya is the worst. Anyone from Putrajaya here? Tak mengaku tiba-tiba. Okay. Putrajaya is very bad for you to do research. People do not going to participate. Yeah? So you will adjust for design effect. So design effect is very advanced. I will not go into detail, but basically it depends on type of sampling. So the best is simple random sampling. If you use simple random sampling, or universal sampling means you take everybody, then design effect is 1. What does it mean? Whatever sample size you get, multiply that number, 1. So we won't change lah. But if you do cluster sampling, later you decide what is cluster sampling, then the sample size becomes bigger than 1, maybe 2. What happens? Sample size times 2. So it will depend on design effect. The best is simple random sampling. And then confidence level, the alpha error, the power, stratification, response rate I told just now. So these are the terms that later you will encounter, but I will give some example after this. So those are the basic concept I want you understand. The rest is very technical. I can give you example. If you understand 1, sample size is estimate. 1, 2, the sample size is negotiation between what is the best and what you can achieve. 3, sample size is very objective specific. What are the objective? Represent population or hypothesis testing. Then you are ready to somehow do your research. Okay. So these are prerequisites for you to calculate sample size. You must know the objective. You must know the sampling method. You must know what will be the outcome like, and then what will be the precision for this outcome. Remember that I palpate the abdomen just now. The precision cannot be that precise on not one value. It must be 2 value range, and the range cannot be too small. And you also have to know what statistic test you use before you conduct research. You have this variable, you know already what statistical test to use. You will never know this. Unfortunately, you have to submit your proposal, but the type already given today, started. Okay, I hope, but I'm not sure whether this week enough for you to know what test to use. But at least I hope you also whether can help you. So this one also important for you to determine the best sample size. But will give you the example, the most common example after this. And then you must know what is the power and the confidence level. I will not go into detail about this. You have to learn, guys. You have to read on your own. The title is hypothesis testing. Read about hypothesis testing. There are 2x2 table. You must understand. So the type will teach you that. But I'm telling you, this is one of the most difficult subjects. One of the The most difficult subject is understanding the concept, not philosophy, the concept behind hypothesis testing. And then you will understand what is alpha error, beta error. Okay. Represent population means you want to represent population, state, district, village, institution. Normally when you say population, you will involve one variable, and normally we do prevalence study. Prevalence study means the main outcome, the main measurement is, the main measures will be the prevalent. Prevalent will be proportion, percentage. The next one, you also may be able to, your aim is to measure the mean. So it's not percentage. The variable is not categorical. You know now. That one definitely you have to do. And then the variable now become numerics. So you want the mean instead of proportion. Example like DMF. DMF is decay. M is what? Missing. F is filled for the tooth. Caries. Measure caries. So they measure caries based on DMF. Your dentistry will measure DMF. So whether they have caries or not. So decay, missing, and fill. So they get total teeth. How many? How many total you have to take? So how many of them got this one condition? Total berapa? Malaysia average is around 8. So overall, people have 8 disorder of the teeth. Now, specific. How to measure sample size? Specific single proportion. Represent population kan? It's always about one variable. So I'm talking about single proportion. This is the formula. This is the most common formula. And I believe there's no other formula if you are talking about proportion here. So this is the formula. Whereby Z alpha divided by 2 is the precision. Why you divide by 2? Because you are talking only one side of the normal distribution. So basically, but just remember this. Z alpha 2 is actually 1.96. That's the value. Trust me. At 95%, this is the value, 1.96. Z, this is 1.96. 1.96. Okay, the power of 2. P is the proportion that you expect. Example, like you want to study about hypertension. You believe that the kampung will have hypertension of 40%. So this P is 0.4. 0.4 there. And then 1 minus 0.4. D is the precision that you want. Yeah, it's 40%, but plus minus how many? 5%. So it's going to be 0.05. Because 5% kan? 0.05. So that becomes your sample size. This one you can forget lah. If you don't include this one, also doesn't matter. So actually, how I measure this one? Have you seen this table before? Matriculation or secondary school? I hope you wish you will never see this again, isn't it? You don't have to see this again. I just want to show you how they get 1.96. So actually, 95% is actually when the alpha is 0.05, which is the 5%. Remaining 5%. So you must achieve something less than 5%, the error. So alpha is 0.05 because you divide by 2, 0.025. So here where is 0.025 is 0.025, which is 1.96. So that's the value 1.96. Positive, negative doesn't matter. If you put this side, it becomes positive. How about, and later you will see beta value. So again, beta is for 80%, power is 1 minus beta, so beta is 0.2. Power is 1 minus beta, so beta is 0.2. So you check here where is 0.2, the nearest, 1.84, 0.84. You can ignore the negative value. So example, you can forget about it. Just remember that normally in sample size we always calculate 95% and 80%. So just remember this number, 1.96, 0.84. Enough. Example, study to measure prevalence of hypertension in a village of 1,000 people. So expected prevalence 40%. How you get 40%? From previous studies, from your expectation. What is the precision like? Plus minus 5. So it can, the data here later, you expect your actual result can be from 35 to 45. Because the precision here is 5%. So later you hope your study is up from 35 to 45% range. So if precision is smaller, 1%, sample size will become bigger. Because your target outcome will be from 39 to 41. Smaller range. So this one you adjust according to what you can afford. Or you adjust according to the previous literature. And then normally we take 95% and expected no response 20%. You expect that if you go, you see 100, 20 will not going to respond or agree to participate. So you expect no response 20%, you add another 20% to your sample size. And I will not going to consider design effect here yet. It's very advanced. So you calculate, you add up, so your total sample size is 188.16. This is what I call just now. It's always an estimate. So if you say that, tell me your estimated sample size. 188.16. Something like you measure that moment just now. The question is, what is your estimate sample size for your research? Estimate. 188.16. Sama macam I ask you, what is the fetal weight like? 2.553 kilogram. Same. So that's why I round up to become something round number, 190, 200, doesn't matter. You can go up, but you should not go down. 190. So when you include another 20% or so, it becomes 230 sample size. So sample size you require for the study is 230 sample size. Not 231, not 232. No. It is not estimate. People who die in Badar is not an estimate. People who participated in the war of Badr is not an estimate. Why? The number is 313. So we have register who participated in the war of Badr. Single mean. Just now is single proportion because this is a study to represent population. Single mean, this is the formula for single mean. So what is important for the mean is not the mean, but the standard deviation. This one. So you need to know the standard deviation, not the mean itself. They just want to know your expected standard deviation. So you will learn what is standard deviation then. You will learn mean and you will learn about standard deviation. Learn that now. Understand that well. So this is the formula. So this is the precision. Precision, we use smallest to get largest. So this is precision, yeah. So this is the variation. So you can see that the higher the variation, the bigger the sample size. So the smaller the precision, and so the higher the smaller precision, higher sample size. Very precise, big sample size. Less precise, small sample size. So, of course, we use smallest to get the largest possible. That's the best. But you must also consider your logistics. So, example, like a study to measure average DMF among adults in village of 2,000 people. Estimated DMF is 11 deviation of 10 with the precision of 2 at 95% confidence interval. So this is I put 95 confidence interval so that I know I have to multiply by 1.96 coming from this information. This one is the standard deviation. This one is the precision. So this one I don't use. Standard deviation. The formula, I need around 96.04 sample. So you don't say 96.04 sample. You say 100. But this one I don't include the non-response. Then you have to include the non-response after that, if you want. Okay. And then we go to the next objective. If you want to test hypothesis. An example like how one variable is different from the other. So at least you have two variables now. So I will limit the calculation up to 2 sample only, 2 variable only. If I include 3, become very complicated formula. Okay, but don't worry, we have a solution for that. So this is the formula. Two proportion. This is the formula. Okay. And this, when these two proportion, what n will calculate is always for one group, one of the group. Because you are always compare two population. You want to compare male and female, so two groups, male and female. So sample size only calculate for one. So if you want to sample everybody, times 2. This is the complete formula is even more complicated than this. Because now I assume that male and female you will take around the same. Because you have not really do the study yet. So you know that you don't really know how many male, how many female involved. So normally it's 1-to-1 ratio. So I assume, this one is assumed, everything is 1-to-1 ratio. But real formula can accommodate to, if not 1-to-1. So you can imagine 1 over k would be under, this is mathematics, 1 over k would be under P1, 1 minus over k. That is different. We're not going to dwell into details about this. Okay. So P1 and P2 are the expected sample proportion of the two groups. Because you want to compare hypertension between male and female. So you must know the expectation, what is the value in male and the value in female. You must give some estimate. And then Z1, you know already 1.96. So beta now you know is 0.84. I told you just now. Just remember that. So here, just now, previously, you have the confidence level, but you don't have power. When you calculate single mean and single proportion. But when you have more than two variables, you must have power now. So, example, a study to compare prevalence of diabetes mellitus between male and female. Expected prevalence 30% versus 40% respectively. Doesn't matter kalau you tukar female-male, the formula is P1 and P2. P1 for male, P2 for female, or you change, doesn't matter. It won't make any difference. Because there's always square there, so the negative is not really important. So power 80% at 95% confidence level. So you put the Z for alpha divided by 2, Z for beta, and then this is the formula just now. And then you minus, this is the difference of proportion, P1 minus P2. Regardless of P2 minus P1 doesn't matter because you always square it. So ultimately you get around 355. So I put round to 360. Estimate. I want you to always remember this. Total sample size times 2, 720 sample size. Compare 2 means, this is the formula, compare 2 means. Again, they use the standard deviation, and actually the formula almost the same, except now they will add the beta, and then they multiply. Why? Because now we become a two sample, yeah. So D is smallest mean differences. Again, the precision. So if this is very precise, the sample very big. The variance is very big. The sample also very big. So total. This is very nice. If I ask for an MCQ, if you understand what I mean, who will give more sample size? High precision, low precision. If you understand the concept, that MCQ will be very easy to answer. But if you don't understand, you memorize just the formula. In fact, you do not have to memorize formula because later I show you why. A study to compare mean of HbA1c between diabetic treated with new drugs versus the standard drug, which is the control. Expected difference of not quite the difference. Expected means was actually 10.5% versus N 11.5. This is English, and standard deviation for both is basically 5%. So we include in the formula, which is very easy, 2 times the deviation, and then this is the precision, which is so this is the variance. This is the difference. The difference is basically minus these 2. So, and then this is your alpha and your beta. So you get 395. 2 sample becomes 790 sample size required. Yeah. Because the precision you expect is between this one. So, yeah. the expected difference is only 1% you expect difference. But if you expect difference 2%, you put here 2%, sample size become smaller. Okay, yes. What do you think? What do you think? It depends on what you use up here. Because you will nullify. If up here you use 0.5, everything will get the same. Okay, this is using application. Okay, now. Okay, having said all those things, there are applications to help you. One is PS Power and Sample Size, free. You can download from that website, or you can Google for PS Power and Sample Size. And then Epi Info and Open Epi. These are all free. Open Epi, you don't have to install anything. It's a web-based application. So don't have to open. Just go to the website or openepi.com. There will be formula, how to analyze, everything for you. But this one you have to download and install. Epi Info 7. This one you have to download and install. Both are free. I don't give you the one that paid. I know you never pay. So now we'll see. Epi Info, yeah? We'll go to Epi Info first. So now, under statistic calculator, sample size and power, let's say we go for single or population, represent population survey. Let's say, example, just now we give 1,000 people. The prevalence is 40%. The precision was 5%. Is it 5%? I put there, I can remember my example just now. 2, Precision, 5%. So 40%. Okay? So the sample size is, so 40%, precision 5%. So the sample size at 95% confidence is 269. A bit different. The formula is, there will be different because this is by different, there is some certain different adjustment for n. So, but doesn't matter because this is estimate. So this 230, this one is 200 and something more, the more than what I calculated. This one is 270, have yet to include the non-response. But this one, after considering this 1000 effect, this formula here, I do not include the population correction. This one formula already applied population correction because you specify the population. So if you have this software, so you don't have to memorize the formula. But you must know that the formula is for what? So you must mention that you will use a formula for a single proportion. Understand? Never ever mention that you use Epi Info. You mention that you use a formula for single proportion. Then you can refer to Epi Info if you want to. But the formula for what? If you put single proportion, then people will know what kind of formula is that. Now, the next one is regarding proportion. 2 proportion you can have here. Alamak. Okay. Now, next one, yeah. The 2 proportion. So, under Epi Info, you click for cohort of cross-sectional. So, here is where you can specify for the 2 proportion. Look carefully, make sure you understand this, make sure you know how to do this. So, confidence, normally I said you take 95%. The power is normally take 80%. And the ratio, exposed, not exposed. Example like female or male. 1, So they will use exposed, not exposed. Actually, there are two groups. So which one? Doesn't matter which one first. So, and again, doesn't matter whether among the exposed or not exposed first. Just now, we want to compare 30% versus 40%. So 40% first, or 30%, doesn't matter. And then, these last three box, don't bother about these two. Risk ratio or ratio, don't bother. Just, this is percent among the exposed, percent among the unexposed, percent among the exposed. So if that is 40%, the 30% should put here, not these two. One of the research applied for grant use wrong formula. Okay, now the sample size required is calculated over there, 750. This one already applied for continuity correction. Again, this is where the formula become a bit different because they add in few things. But the actual formula is the same what I just wrote in the presentation. So whether you take this one or that one, this is the formula by Fleiss. F-L-E-I-S-S. So Fleiss, there are many versions of two proportion, but this one by Fleiss. So I can't remember, is it 1965 or 1988? I can't remember the formula. I can't remember the reference. So those are 750 sample size. If they wrote there 752, but when you plan, it should not be 752. Around the number 760 or 750 doesn't matter. It's about, because it's always an estimate. Any questions so far? Now, AppInfo cannot measure mean. So you have to rely on another software, which is PS Power and Sample Size. You have to install first. Then you open Power and Sample Size. For the mean, you use this button over here, t-test, because it is a 2 mean, so you compare the t-test, sample size, is it paired or independent? It is independent. What do I mean by independent? The two mean value, one mean for the male, one mean for the female, so it is not related. Unless it is the mean before the exercise, the mean what value, mean after exercise. For the same people, and that is related. Because the mean after is affected by the mean before. Then this data, this means related. But the mean for male and the mean for female is two independent groups, not the same people. Alpha is 0.05. You cannot use 5% and use decimal point. Power is 0.8. The difference you expect, just now, DMF, you need one. You can put 1 there, because as long as down there also you put not a percentage, yeah? Okay, 1. The difference, the variation, 5%. So 5. The M is the ratio between the groups, is 1. If you do not understand, just click here. They will guide you what it is. Calculate. Is it the same? 390. Remember 390 approximately, just like previously. So we need around 400 samples here for one group. You need two groups, right? So you need 400 sample size, 600, 400, 800 sample size, approximately 800 sample size. How about single mean? Single mean kat mana nak buat? Single mean. Okay, this is an open API. Unfortunately, single mean not available free. I cannot find. Oh, not from the 3 references I gave you, but you always can find from the online calculator. I forgot what the single mean. I have single proportion, 2 proportions, 2 means. But I forgot to include how to calculate for a single mean. For a single mean. I have a software, but no point showing you my software because that is expensive, $1,000 US. Okay, any question? Okay, yes. I told you, okay, what to check. This is open FP, how the layout like, but the calculation is almost the same, exactly the same, not almost exactly the same. This is dichotomous. This is if you want to use two proportion using TF power and sample size. So you will get about the same, and compared to means also same. So this is the reference I told you about. I will leave the reference. I'm very kind enough. 2 copies, there are 2 references, there are 2 copies here. I wish you good luck to read these references. You can understand if you want. I will never give you the slide, but you can see the how the formula everything they run. Yeah? I wish you good luck to read this paper. Any question? Yes. Single proportion, yeah. So akan kita there should be square. Always refer back here, yeah.